So with that, so that's the solution. That's an ecosystem world. So now what we want to do is, we've obviously done a lot of slides. We want to actually walk through a use case. So I'll quickly cover a use case, show how the solution would look like, and then Basir here will actually show it in operation. So we can keep it interactive in this case. So this is, again, from a customer journeys perspective. We have laid out these use cases from a customer journeys perspective. Now, obviously, we have north of 2,500 customers, and they are making decisions to move to the cloud. In some cases, keeping behind the tools in the on-premises, but want to access the traffic in the cloud, extending their security or network performance posture. So the scenario here is simple, right? I have purchased it. I have a big CapEx spend on my tools in the on-premises. I don't want to throw that away because my data centers aren't going away, but I still have to, all the new applications are in the cloud. How do I extend this posture between what I've invested here versus what's going on in the cloud? So that's the scenario here. The way this would work is, imagine the scenario, right? You have a big investment in the on-premises. You already have your security posture, getting traffic from the Gigamon platform in the on-premises. And then you have already our orchestration layer. So the way this would work is we integrate with the tier, the APIs, deploy our solution there. Again, all start off with whatever your customer's profile is, maybe one node, maybe multiple nodes, but the visibility tier in the cloud. Acquire the traffic from those instances. Then you have a decision point. Do I want to send all the traffic to the cloud, in the tools in the cloud? Or do I want to backhaul it back to the Gigamon platform here so I can recoup some of the investment that I've already made, right? Because it's not necessary that all these tools have a variant in the cloud, but this is pretty big investment that they have made. They can backhaul the traffic here, and then now all these tools can acquire or analyze the traffic as well. So basically, this posture that you have invested in now can be extended into the cloud as well, right? Again, this is standard protocol, L2GRE. Our box does the our platform does the decapsulation here, and then can replicate the traffic to all the tools. Some of the traffic intelligence functions that Greg showed are all in this platform. So for example, if you want to do out-of-band SSL decryption, you could do that here, right? Or maybe generate net flow, for example, you can do that here. But you have the traffic. That's the more important part. Now, from a costing perspective, customers are thinking about what is this cost? Obviously, anything egressing Amazon has a cost associated with it. They might have negotiated a good direct connect price with Amazon, and they can probably use that to backhaul this traffic as well. So this is where we are seeing our customer journey start, right? And maybe they'll move these to the cloud, but they're not there yet, right? So we'll pause here for a minute. I'm going to hand it over to Basir to walk through this demo. And then because it's the first demo, we'll show some of the other functions as well. So that way we'll set that as a baseline, and then we'll cover the other use cases. Any questions before I hand it over to Basir from a...
So I kind of want to go back to my question again. So great. Let's say that a customer does do lift and shift, and I have a whole... I'm very skeptical of this because I've seen this just fail miserably, this process. But let's say you've got a customer that does that, and then they start to refactor those applications into more ephemeral architectures, right? So containers, microservices, et cetera. Where does your solution go from there? Because unless I've missed something, it seems like you're resilient on that VM. You're requiring that VM, so which would go away.
So if you can pause two more slides, we'll actually cover that specific use case as to how we do plan to address that. Obviously, some are in our roadmap, so I can definitely talk off camera about it. But definitely what we have today and where we are seeing customers with containers, I can talk about how they are acquiring the traffic with that world as well. So a couple of more use cases from this, then we'll get back to that. Okay. Any other questions before you're absolutely right. If I look at a customer base, they're probably between this use case and the next use case, that is probably our 80 to 90% of the gamut, or 80% maybe, and the other 20% are thinking about that exactly to your point, they're refactoring this into the future, and then how do you get access to the traffic?
It just seems, I'll just be candid. It just seems like you're currently targeting a percent of the potential base of customers that are going to be leveraged in terms of workloads that are going to be leveraging public cloud. It seems like a very limited use case.
So I will make the case that out of from our customer base that we have today, right? Let's take that as an example when we'll talk about the other million that Amazon enables. Out of our customer base, probably a much, much, much smaller percent is looking at that ephemeral architecture. They're in this world today. And I'll cover the one that we are looking at, that ephemeral architecture as well, because we know the world will land there, right? And that gives us a wider exposure of how to get access to the traffic. And I'll get to that in a couple of slides.
So what I'm going to start off with is, this is our Fabric Manager. Our Fabric Manager is the orchestration application. It's the one that manages the physical nodes, the virtual nodes over across VMware, OpenStack, and AWS. In this use case, what I'm going to demo is how my applications are living in AWS, but my FM is living on-prem, and the traffic is being tunneled or backhauled back to on-site into our FM, and then from there, the traffic is being fed both to the tools that are in the cloud and the tools that are attached to our physical appliance, in this case, an HC2. So before I get into the AWS portion of it, I'm going to quickly just show the map where it shows. So this is the tunnel that's coming in from the traffic from AWS. It's being fed to the physical appliance, and the physical appliance, it's doing a couple of things. It's hitting a Plexar a NetFlow tool. It's also hitting a Wireshark that's sitting behind.
You maximize
Maybe you want to
your
show
screen.
the mouse to say where the tools are, which tools they are. No, right there.
There you go. Thank you. That helps.
Okay. There it is.
There you
Okay. So traffic is coming in from AWS. It's hitting our physical appliance. It is going to a Plexar, which is a NetFlow aggregator. It's going to a Wireshark that's in the cloud. So this is where, if we move our mouse over, it shows the flow of how the traffic is coming into it and which path it's taking to get to that. So that was just a quick view of that. From there, we're going to go and look at the actual FM itself. We want to focus on the cloud portion of it. So one of the first things that we do once FM is up and running, and again, FM could live in AWS, FM could live on a virtual machine, or FM could live on a physical machine. So it depends on the customer's preference. The next thing we do is this is where we establish our connection into the VPCs. So we have our individual VPC IDs, we have our availability zones. So that's the first thing that we do. The next thing we do is we deploy the controllers within the VPC. And the controllers basically act as proxy. Because FM is living on-prem, we don't want to open up all these different port IP addresses between all the agents and FM. So the two controllers act as proxies for FM to manage the environment within the VPC. The next component is the vSeries node. This is our virtual aggregator. This is the one that acquires the traffic once, applies filters, applies intelligence, and then from there it gets sent down to the tools. And so the vSeries node is the one that's automatically scales up. The next thing that we have is our tunnel library. So this is where you specify the end tools that need to receive this traffic. So in our case, I have four, two of them are the physical machines, two of them are the virtual machines, but we're sending traffic to them using L2 GRE. But if we wanted to, we could do tool, we could do either GRE or VXLAN, and basically the rules, as long as the tool can decapsulate a VXLAN or a GRE and there's an IP route to it, we can send traffic to it. It's that simple. All right, so I call this the backend infrastructure. And one of the things I want to point out is by default, we have a rule that says that for every 25 agents or taps, we have a vSeries node. But this is a range, so you could do 1 to 1 or you could do 1 to 50. And so if you do, let's say, 1 to 50 and a 51st agent comes online, FM will automatically deploy a new vSeries node to be able to accommodate traffic from 51 through 100. So this is all part of our automatic target selection and automatic how the environment grows as it scales out.
So to pause on this, to go back to your question, so this is where eventually when we do, the ephemeral instances do come up, whether it's containers or whether it's EC2 instances that live and die in a short while, these numbers, you set up the profiles so that the instances automatically spin up. So you're not actually manually hand-holding the spin up of this architecture. You've set up a profile, and based on how many you're acquiring at a given time, you can scale out your visibility tier accordingly. Where we acquire the traffic, I'll still get back to you on that when we get to the other slide.
But you have to spin this up as part of that instance?
So no, this is a profile that you set up,
Yeah.
right? First of all, Basir has an example that shows 2 of them. You can start off with one vSeries node. One of them is actually deployed. And then let's say they're tied to 50 instances from which we acquire the traffic. The 51st instance comes up. Fabric Manager is watching these events. It's automatically spinning up the next node or the next visibility tier node automatically without any user intervention.
What are you defining as a node?
So, okay, we are using the node and the EC2 instance pretty liberally here. So the EC2 instance for our software. This is actually, the software is a packaged AMI. If you think about it, it's already an AMI that actually has our software. It's a Linux OS built in with our software in it. And that's the AMI that's available in the cloud. That's what we publish. And then that instance is what Basir has launched. Go back to the vSeries node, for example. So that node which we launched, the connection that we launched, is actually set up to instantiate that EC2 AMI already, the Gigamon's AMI.
But I guess, sorry to interrupt, but I guess what I'm saying is, so the smallest component that you break down to is the instance, the EC2 instance. You don't go further than that.
For our tier, you mean?
For where you can go. So my question was around containers and microservices, right? Which goes further.
So today,
than that, right?
Our agent doesn't live in the containers; it lives in the EC2 instances. So if the containers live in EC2 instances, we can obviously use our agent there.
Okay.
So that's one way to acquire traffic. So anything going in that EC2 instance, we got it, right? What we are looking at, and as we'll address it, what we are looking at is if you have a container service router, for example, that sits higher than the EC2, than the containers themselves, whether it's Nginx, whether it is, Netflix has talked about Zool as an option for the containers. So we're looking at those places to acquire traffic. A container is too small to put any agent in there, right? It's just not worth for it to, it doesn't even stay that long for it to come up and then do all that.
But you do have visibility at an EC2 instance or on-prem instance for viewing container, inter-container traffic as long as it goes over the wire.
Right, exactly. So if you haven't, let's say...
And it's not encrypted, because if it's encrypted from internally of the container somewhere else, you're not going to be able to...
So
use the same.
let's double click on that. Sorry, Basir. So let's answer this. Let's take this on, right? So let's assume you have an ECS. ECS spins up a cluster of EC2 instances and deploys and use that to deploy containers on top of them, right? Now you can bake those EC2 instances with our agent. So any containers deployed in those EC2 instances, we can get traffic to, because everything hitting that ENI out of that EC2 instance, we got access to it. Now, what challenges we are working with with Amazon is the east-west traffic from a container to another container that doesn't go to the ENI. How do you acquire the traffic? Now, there'll be multiple ways to, we are obviously looking at that, and we can have a deeper conversation about it. What we are thinking of a world is containers not living in an EC2 instance. How do you get access to that traffic? You cannot put an agent in there. That's where this higher level layer of whether it is a service router, a container service router maybe, right? Nginx has some examples through it, or HA proxy, if that is what is acting on it. We were actually clued in by one of our customers to say they were using a Netflix Zool router as an option to do that.
So in the same way as we were saying before, if you're going to need visibility into cloud native things, you've got to route traffic through something
exactly
that you can get visibility on.
I mean, the other approach is put an agent in the container, and we all know that's not the place.
That's not going to happen.
That's not going to happen, right? I mean, it's too heavy for it to happen. So you got to look at a higher level abstraction to go access the traffic. A perfect example is Amazon gives it to us natively, right? And that's how we have built our architecture to acquire.
I mean, is there any chance of Amazon, as you're partnering with them, to have literally on the wire?
We are, and I can talk to you.
Is that because obviously you're requesting it? Is that because Amazon and Azure are interested to help their enterprise customers who want that visibility? Because ultimately, I would think Microsoft and Amazon wouldn't want anybody else looking at anything on the wire. But is it a request that they're seeing from their enterprise customers going, hang on, we're freaking about what's going on the Amazon and Azure wires, so we want someone like Gigamon to help?
So
you know which
yes,
direction?
yes and yes. The answer is yes and yes. So there are three ways that customers, that Amazon and Azure are coming to this party. One is the tool ecosystem that says, hey, they're pretty big players, I mean, like a Splunk or RSA with Dell's backing and so on. They go to Amazon and say, hey, our customers are asking for this traffic. How would you do it? Right? That's one use case. The second use case, customers directly going to Azure and Amazon and saying, we need access to this. So we have had many examples where a conversation starts like this. Customer goes to Amazon solution architect and says, hey, I want visibility into this traffic. Amazon solution architect turns around to Gigamon and says, hey, can you help these guys? Because we know this option, right? And the third one is from a technology perspective itself. I mean, what would be cool is on a virtual switch in a private cloud, you can get traffic out of the virtual switch, right? Amazon or Azure don't do that natively in the span function. We are obviously having good conversations with them to see if they can enable that function, so we can just be the acquisition layer. Right? Our agent is a way to acquire traffic wherever it is, but we would rather spend the time on our intelligence layer, acquiring it, doing all the nice things before delivering to the tool, than spend time on the acquisition part. Right now, because there's no other way we are doing it through the agent, but obviously we are working with Amazon and Azure to see if there are other ways to get it. Whether it is from Lambda function to a Kinesis, a Lambda function to a container in the future. If we can get access to this packet somehow and then feed it into our layer, got it. That's how we are looking at it. And then we have designed this, I mean, as you can probably tell from the architecture, the acquisition source is through the agent right now, but we have designed it in such a way that it can land from anywhere else.
So I still have a myriad of questions about just centralized public cloud. What happens when this moves to the edge? Right? What happens when we start to bring IoT and the edge into the mix?
So that's a good question. So, well, we can go back to the slides, or
because a lot of what you're saying doesn't apply when you start to bring in IoT in the edge.
So okay, so let's take IoT example. So what happens in an IoT example? Let's take a car example. In fact, we were in a conversation in Dallas, a combination between us and the customer and the IoT vendor. So they actually have somewhere where at the edge they are streaming it up to an analysis tool in the cloud, right? I mean, their traffic is probably in the car manufacturing plant somewhere, and those machines are actually sending traffic to their cloud instances for analysis. Now, if that analysis is done in the cloud, obviously that application that's doing the analysis, we can get traffic from there because the IoT edge is actually streaming it up to a cloud. Or IoT gateway, edge gateway is probably streaming it up the cloud analysis.
That's a big assumption. I think there are some use cases where IoT will feed up to public cloud, but there are an increasing number of use cases where only the combined data will ultimately end up in public cloud after the fact, long after the fact, but the processing is being pushed out to the edge. Okay. Because of latency and other challenges, right?
So let's take that use case. So we obviously have our physical variant as well. So in fact, one of the things that we are looking at on the physical side as well is, let's take that same car manufacturing plant that is doing the IoT access, the traffic access to the IoT devices. There's no reason that gateway that is sitting in the edge, we cannot tap those links in the physical on-premise at the edge to acquire traffic to the Gigamon platform as well. There's no reason why we cannot do it in the on-premises itself, right? We can look at, we can tap those links because the assumption is an IoT edge is getting traffic from an appliance that's sending information to it. And if that is going over the wire in the on-premises, there's no reason why we cannot tap it there. You see where? Maybe we can have an offline conversation if this is.
Yeah, because
let's do that. Let's have an offline conversation because I can walk you through the scenario that the customer raised and want to go deploy this to access this. But let's talk about it.
Yeah, because there's more processing that's moving to the edge.
When you say edge to the on-premises in this case,
there is no data center. And when I'm talking about the edge, I'm talking about it's happening in silicon in the device at the edge. There is no data center involved, right? The only time that a data center gets involved or a cloud gets involved is when the aggregated data after the fact gets pushed out. If it gets pushed out. In some cases, it doesn't. It gets dumped and you move on.
Sure.
So I'm just saying, I think this goes back to my fundamental question that I started asking you about, which is step back for a minute. Has there been any pause to say, you know what, maybe our ways of thinking aren't going to apply in the future? Okay? And so then maybe we need to think about a different strategy, a different approach to be able to solve some of these complicated problems that will become the norm. These aren't edge cases. These aren't, let me use a different word just so it's not confusing. Like this edge IoT example is not a corner case. It's going to be a lot of the norm as we start to move forward. And so how do you start to encompass some of these new methodologies, these new paradigms, because traditional thinking need not apply. It doesn't work. It breaks.
Okay.
And so that's where I was trying to kind of pick into your brain to understand, has there been any conversation inside to step back and say, you know what, we can't just refactor what we're doing and tweak it and make it fit in. It's a whole new ball game.
Yeah, so the only point, so we have an IoT expert in the back of the room, so maybe the three of us can talk offline about what we are thinking on the IoT strategy. But going back to whether we are refactoring, that's where I have a small concern, because it is not just refactoring, right? I mean, there are use cases that are out there that can be solved with what we have done. Yes, there are use cases that we have to go back and see if we can either redesign or actually expand on the use cases to acquire the traffic. We will look at that. I mean, obviously, for example, when we started this journey, the transit VPC was something that we hadn't thought about at all. But customers raised it and then said, well, I'm transiting through it. How do I get access to it?
So what drives your thinking? Is your thinking driven by what customers ask for, or is your thinking driven by where you believe the industry is headed? Because those are two vastly different things.
Totally. And you have to keep context of both, right? It's not one or the other, right? Because we're not just
It depends on whether you want to be a leader or a follower.
We would say, obviously we are the market leader in this space. So
For now.
Yeah, that's at this point. And we are seeing the customers move into that direction.
Market share of buggy whips. Yes.
Well, and I don't say that to be disrespectful at all. I'm saying it in that I think it's a dangerous place to be, quite frankly. And I'm not just saying that this is something you are doing, but I've seen other companies where they kind of rest on their laurels and think, okay, we're good, we're the market leader in any particular space, we're listening to our customers, we're delivering products that our customers are asking for, and next thing you know, the customer pivots or a disruptive customer comes into the mix and they're caught flat-footed and they're dead.
So
they're done.
Your point is well taken. So what I would make the case is we're not resting on laurels. So we see the cloud migration happen. So right, for example, we had the private cloud, we had the public cloud, and we are moving along maybe faster than even our customers in some cases. But having said that, we are looking at the IoT strategy, and obviously we'll talk about it, but we can talk about it off camera is all I'm saying. Right? Because there are conversations going on inside the company of how to access traffic. And this use case, and it's obviously at some point customers are looking at how do I apply my current problem and how do I solve it right now, because they have a blind spot. Right? We got to obviously address that. But we are looking at the future to see where will their trajectory move into, and so we can evolve our products as well.
Yeah, so I mean, to give you some credit, I suppose, and pivot things a little bit, you have a heritage which is network-based, which is, right. Back in the day we had physical network devices, you could chuck a tap on it, and a physical tap would go on the wire and you would pull traffic off. That is less true, particularly when we go into something like functions. AWS Lambda, there is no network tap in it.
Exactly.
But then there is also, that's just the data gathering mechanism. There's also all of the stuff you do around data analysis and actually having a pool of stuff which you can then provide to other applications and so on. I'm curious to see if you've looked at things like application tracing, so things like Open Tracing and Prometheus and those sorts of things, where you have application developers in particular are used to using things like app dynamics and so on to do that kind of telemetry information, which is similar to what happens with IoT as well. You've just got this big stream of data coming at you. It's not raw network data, but it's still interesting traffic data that I want to know about. So I'm curious to hear if you've got, if that is plugging into this ecosystem that you have, that instead of being, okay, we have network taps which work on site, we also have network taps that work in virtual machines, we have some other things there, and we have these other things which then pull into our analysis platforms. Right. That collection method may need to change. But a lot of this, analysing data and using statistics, that doesn't really change much.
So we have, let me answer. We obviously use a lot of our help from our ecosystem partners to do the analysis, right? So in some cases, obviously, we don't replicate what they do. But having said that, there are a couple of areas that we are actively looking at that obviously are not ready for roadmap level discussions, are not level to publicly announce from a product perspective. What about big data analytics? Right? How can we, because there's a lot of traffic going through us, can we do real-time analytics that is going through our platform itself? Right? That's one use case. The second is specifically, we have a huge footprint, I would say huge as in a relatively large footprint from our service provider customers, right? Where they might be the gateway for some of the edge IoT traffic coming through them. They are thinking about how do I support IoT in my service provider deployments, right? So we are looking at that as a use case. What about IoT from an application analytics perspective? We are looking at that use case. Now, we are not ready to announce anything yet, but
not just IoT. I'm not just focused on the IoT side of things, but also just around cloud and how that's being done. So things like containers, functions as a service, the way application developers are writing software, and that may be a way of getting access to network data or flow traffic or whatever it might be, data that's moving around from A to B. That maybe you put a tap into the operating system or into the kernel, or maybe it's an application tracing module that you say, hey, wouldn't it be awesome if you baked this into your application that will send traffic along there, but will also provide a network tap capability so that we in security can say all of the applications that are, financial trading applications, we don't tap the network, we just tap straight from the application.
I'm thinking even an example of, say, Lambda functions are grabbing a file and sticking it into a database. There's no reason that two Lambda functions could fire, one controlled by Gigamon, that whenever that Lambda function fires, another one grabs the same data and in parallel sticks it through a security device to check that credit card data isn't being put in an S3 bucket, for example.
So, right.
Application level network tap.
Yeah, that's an interesting.
But it's an interesting use case. But going back to picking on that, typically those Lambda functions are not, obviously they're fired on some event trigger, right? And they're not running an EC2 instance, so you cannot stick anything in there. So in which case we are relying on Amazon or somewhere else to get access to that traffic, and that's where the relationship with Amazon or Azure to get access to that traffic.
Yeah, if you've got some visibility of that event bus, which you can obviously do on.
We can with the CloudWatch. We will. So what we can do, what we are looking at, what I can talk about, what we are looking at is, let's say because we have connectivity to the CloudWatch, we can know if a certain Lambda function was triggered, right? And then maybe that's one way to feed those events probably to the tools without accessing the traffic itself, but at least you can identify which Lambda function fired. What did it say? What did it do to somebody else? The other approach,
on your initial three things, you had metadata as the middle one, and CloudWatch is all about metadata.
Exactly,
you may not have the visibility exactly of the traffic,
the packets, but
you know what's talking to
exactly,
what.
Exactly.
Okay.
That's an option. The other option we could think about is, let's say you're running Kubernetes as an orchestration platform, deploying containers from an ephemeral perspective. Maybe that's the metadata as well. Look to see how much of the containers have been deployed, how much have been toned down, and if the SIM, for example, needs access to that traffic, right? Maybe we can grab it from the Kubernetes platform, or if the Kubernetes is integrated with CloudWatch for all the eventing, maybe we can grab that, generate metadata off of that if needed. Those are some cases that we can see, but obviously the packets themselves are not available, but the access to what might have happened is available. Go grab. All right, switching back into the demo.
All right. Okay, so we've got the backend infrastructure up and running. Now the next thing we want to do is very quickly, I just wanted to show you guys asked the question about what is that we see and we don't see. So in this case, we've got the agents installed. So the agents are highlighted in blue because they have the agents installed on them. But the other things that we do see within the VPCs that do not have the agents installed, because of our tight API integrations with the EC2 APIs, we see everything that's running within the VPC, even though they don't have the agents installed. So that's just one of the things that we provide very quickly, very high level, and this depends on your VPC. If you had a long list of VPCs, you could see what's running in there. So that's a topology a view of the environment. The next thing we do is we have this thing called a monitoring session. So this is where we are creating rules that can go and target the traffic from those agents and then send it on to the tools. So in my case, I'm sending the traffic, like I said, to the physical appliance right here, and to my two tools that are living in AWS. And I am going to come out of full screen because I need to switch over. So if I come out of here. One of the, well, I'm sorry, I can't do this in full screen because I have the.
It's okay.
Yeah.
Okay.
So I wanted to show, I don't want to bombard you guys with a bunch of Wireshark instances and a bunch of it's just too much data, but I just wanted to very quickly just show, so right now, when I hit the H, I have my orange HMR tool that I'm going to log into.
What we have done this is basically we have set up a set of compute instances. We have deployed a 3-tier architecture application. The Orange HRM is an open source application, so we've deployed it there. Then we're going to simulate some activity to make sure that that traffic is acquired and analyzed by multiple tools. So
this Wireshark right here, this is the one that's attached to our physical appliance. This is the Wireshark that's attached to our, I'm going to stop, that's living in the cloud. Bring it all the way down. And then I also have our NetFlow analyzer, right? So this is and I want to do search for the IP address of the HMR appliance. So go in here, oops, sorry. Do search for it. Oops, sorry about that. So come here. All right, so the point I'm trying to make is the 3 different tools are receiving the same traffic at the same time. So as I maneuver around through the application and we click on different components, as the Wiresharks in the background, I'll try to minimize this, are reacting to the traffic as it's flowing. So our solution is feeding tools in the cloud and behind our appliance all at the same time with the different clicks that I'm doing through the application. Okay, so that's one. Another thing that I wanted to showcase is how quickly we're able to see traffic.
I want to pick up on this example, and I think somebody asked about the SQL injection. So in this case, if there's a nefarious user doing SQL injection, and if our agents, our solution is getting traffic from the app tier, then you can obviously, a security tool can actually point that out that there's a SQL injection error in there as well, right? That's the use case behind this.
And in this case, so right now, our solution is seeing the 6 agents that are up and running. So let's go ahead and power on a couple more of these agents to showcase how quickly we're able to auto-discover machines as they power on. So we'll go ahead and power these machines on, and this is where, we'll continue talking. So one of the things that I also wanted to showcase is, let's say we talked about how traffic is expensive egressing out of AWS, and it costs money to do that. So we wanted to limit the amount of traffic that's being sent back to our on-prem Wireshark, for example. So what we can do is we could delete the map, bring our sampling capability, and say that we want our Wireshark that's on-prem to receive only 1 out of every 10 packets. Then click that, click on deploy. Now, as we see, both of the Wiresharks saw the traffic that got generated, but this Wireshark is now going to receive one out of every 10 packets. And I think the easiest way of doing that is probably just pinging one of the machines, so I'll just go ahead and the idea behind this, obviously, is if a cloud-native tool needs to see everything, but the on-prem tool only needs to see some parts of it, and you can save your backhaul costs by doing a coarse grain to the on-premise tool versus a fine grain to the cloud-based tool.
Or you want to sort of, something is wrong, you don't want to capture all the traffic, it's going to kill you, so it's going to give you a direction to go in.
Right.
Also some general analytics of what sort of normal is.
Right, exactly. And so they might typically, because of the cost is a consideration, so in using our APIs, you can start with coarse grain, right? And then you see something going on from deviant from the baseline, then you want to get a fine grain for that specific traffic maybe. Again, you can use different variants.
Yes, obviously it's different use cases. If you're looking back to do analytics on a breach, you want all the data.
Right.
But if you're looking at a performance issue and trying to narrow down where you need to investigate more.
Yeah. So this is the tool that's on-prem is receiving 1 out of 10 packets, whereas the Wireshark on the cloud is receiving all the traffic right there. But we also have the capability of, OK, so now we're also looking at 9 machines. Before it was 6. So it auto-discovers those 3 machines that are powered on. So this is our automatic target selection capability. So now any traffic hitting those 3 extra machines will automatically also be seen automatically. There's nothing we need to do about it. They're auto-discovered. But going back into here, we could also do slicing. And we could also do masking of the packets, just like how we did with the sampling. So depending on what the need is, we have that capability of reducing the amount of traffic depending on the need on how the tool receives that.
So an example of the slicing obviously is, maybe you don't need the entire payload. Maybe you look at the headers plus some offset, and then maybe based on that, you want to actually get the full granular packet itself. So that's another option.
And as Sesh said, everything that I'm showing you can be done through APIs. So I'm showing you through GUI and through manually, but all of this can happen through our APIs. And as Sesh said earlier also, we do have the different ways. We could do a test drive. We could do also a quick start. So we have different ways for customers to deploy this solution into their existing environment. So this is our test drive where customers give us 4 lines of information. Within 15 minutes, an environment gets deployed within our account, and they can play with the software for 3 hours on their own. That's very easy to do. But let's say the customer wants to do this in their own account, and they want to play with the software. So give us 8 lines of information. Our automation deploys a new VPC into your customer's account. It deploys the full solution into their environment. They have 30 days to play with it, and they have 10 machines that they could tap to get real live traffic access on their own.
Are customers happy giving you their AWS secret key and private keys?
So so one of the things that we recommend in our checklist is give us the keys, let us enable the environment, disable those keys, make them inactive, and then when you're ready, if you want to proceed forward, keep them inactive, and then you could just VPC peering with the environment and build upon top of that. If you don't want to use the environment anymore, there's a link that will auto-delete the entire environment. Reactivate the key, hit delete, the whole environment gets deleted automatically on its own, and then you could delete those keys.
Okay, so there are ways to do it in a slightly more secure.
And then we also
Oh, there's also one more thing. Before the customer can access the environment, they have to go into their account and open up the security group to allow inbound from their IP address.
Yeah.
So yeah, security group is tied down on purpose so that we can't from outside, we can't access it. Only they can once they're within the console.
But the advantage here is you've got a fully automated deployment to get up and running really easy.
Yes, so within 20 minutes, you could play with the software for 30 days on your own. Yeah, and there's of course, you could access this through the AWS marketplace. So as Sesh said earlier, you could do. So this one has our CloudFormation template. So if we do search for Gigamon, and we go in here, we do have our CloudFormation template that you could either download, or this will deploy into your existing VPC. Or if you're within a EC2 console, and then, go to here, launch, and then do a search for AWS Marketplace, you could also find the solution from here, and then deploy this manually into your existing environment. So we've made this very easy for customers to deploy. That's
right.
Yeah.
And then again, we'll cover this the summary of all the automation frameworks built in to support this. The one thing that we also do is that Quick Start is built using Terraform. So if a customer says, hey, you know what, I don't want you to deploy into my environment, give me the Terraform scripts of this entire deployment, we can actually give that to them as well if they want to bake into their own automation sequence.